Hi, my name is Paul, and today I'll be presenting my Physics 2212 lab on charge tapes. In this lab report, we will be creating charge tapes and identifying their charges by the interactions with other objects of known charges. Next, we will use two charge tapes and determine the exact charge on each of the pieces of tape. Finally, we will create a model of the floating tapes experiment in GlowScript. As a quick aside, we will note that for the entirety of this experiment, that the charge of the tape acts as a point charge at the center of the tape. The density of the tape is known to be 1 gram per meter, and there are no forces acting on the tape besides from the gravitational and electrical forces. We also see that the Coulomb's law and Newton's first and second laws describe the interactions of the tape. We begin the experiment by taking two pieces of tape that are 0.2 meters long and folding the end to make a handle. This is referred to as a U-tape. The U-tapes were then stuck to a neutral piece of tape and separated quickly, inducing a charge on both pieces of tape. For the experiment, it is important that the tape only be touched on the handle as to not neutralize the tape. The tape was then hung up on a surface and tested for interactions with other objects. The two U-tapes were tested for interactions with the experimenter's hand, a negatively charged pen that was given a negative charge by rubbing it with a cloth, and each other. The results showed that both U-tapes were positively charged. The two pieces of U-tape are then carefully hung a distance of b apart, and then the distance at the bottom is measured as the distance a, which was 0.04 meters. From the known density of the tape, we know that the mass of the tape is 0.0002 kilograms, given that the length of the piece of tape is 0.2 meters. From this, we can calculate the gravitational force acting on one of the pieces of tape as 1.96 times 10 to the power of negative 3 newtons. Since the piece of tape is suspended there, we know that the electrical force must be equal in magnitude in the y direction. For purposes of this experiment, we will consider the magnitude of the electrical force in the x direction to be negligible. Hence, we can calculate the charge on one of the pieces of tape is 1.9 times 10 to the power of negative 8 coulomb. We will assume that the two pieces of tape have the same charge. For the shown calculations, we will make the assumption that an atom is perfectly square and two-dimensional with a side length of 1 times 10 to the power of negative 10 meters, and that there are more atoms than electrons. We begin by calculating the number of electrons by dividing the charge of the tape by the elementary charge, giving us that there are 1.19 times 10 to the power of 11 electrons in excess. Then, we can calculate the number of atoms on the tape by dividing the area of the piece of tape by the area of an atom, giving that there are 4 times 10 to the power of 17 atoms on the piece of tape. Finally, we can calculate the ratio of excess electrons to atoms as 2.975 times 10 to the power of negative 7, which clearly shows that the tape is positively charged. Finally, a GlowScript model was created from the experimental data to show the forces balancing out on both pieces of tape. The charges on the tape are treated as point charges at the center of the tape, so that the gravitational force and the electrical forces are acting at the same point and cancel each other out. GlowScript merely illustrates the forces acting on each piece of tape, showing that both are experiencing the same forces since they both have the same charge and same mass. Thank you for watching.